For as long as we've dreamed of the stars, we've been bound by a single, unyielding law, the rocket equation. It dictates a harsh reality. Every extra bit of speed, distance, or cargo demands more fuel, which itself adds weight. To lift that extra fuel, you need even more fuel. It's a relentless cycle, a cosmic catch-22. Every mission is a masterclass in compromise, with planners forced into agonizing negotiations with physics. Add more instruments. That's more weight, more fuel, more trade-offs. The dreams of engineers are whittled down, not by imagination, but by the finite capacity of a fuel tank. We launch spacecraft that are mostly fuel, with the precious payload, a tiny fraction, tucked inside. Imagine planning a road trip with only the gas you can carry from the start. No refills, no stops. Every mile, every detour, every souvenir is measured against that dwindling supply. This is the reality for every space mission, a one-shot gamble where the fuel gauge dictates destiny. So, we've become experts in efficiency, using gravity assists, designing looping, fuel-saving paths that take years. But what if we could change the rules? What if fuel wasn't just a burden, but a resource you could access along the way? Every space mission faces a monumental challenge. Pack everything, fuel included, for the entire journey into one launch. It's like an explorer setting sail with not just provisions, but all the wood to build every port along the way. This all-up strategy forces us to build massive rockets, most of their bulk just fuel to escape Earth's gravity. Every kilogram is precious, and when most of it is fuel for later stages, the cost of ambition skyrockets. Spacecraft must be built to survive a violent launch, then be as lightweight as possible to save fuel. We can't launch large, modular habitats for Mars in one go. Instead, we're forced into smaller, lighter components. This approach favors small, robotic probes over large, human missions and makes outer solar system journeys decades long. Building large structures in space becomes a logistical nightmare. We're trapped in a cycle of disposable, single-use vehicles because launching return trip fuel is often too costly. Our grandest dreams remain on the drawing board, limited by the tyranny of the fuel tank. This is the reality. We explore the cosmos with the equivalent of a disposable car, but what if we could break this cycle? What if we could refuel along the way? Imagine a future where fuel is a resource to be accessed, not a burden to be carried. Picture a gas station in space, a depot orbiting above Earth. Spacecraft could launch with just enough fuel to reach this orbital oasis, then refuel for the journey ahead. Suddenly the rocket equation's grip loosens. Missions become longer, more flexible. A trip to Mars isn't a one-shot dash, but a journey with options. Spacecraft could visit Mars, then its moons, or change plans if discoveries arise. Payloads could grow. Larger habitats, bigger telescopes, more ambitious missions. Components for Mars missions could be launched separately, assembled, and fueled in orbit. The size of our spacecraft would no longer be dictated by launch shrouds. New mission types emerge. Reusable space tugs. Rapid response comet studies, servicing missions for satellites. Refueling doesn't just improve current missions, it unlocks entirely new possibilities. The paradigm of space exploration is transformed. The cosmos becomes a network of destinations, not a single perilous leap. The idea of infrastructure enabling exploration is as old as civilization itself. Sailing ships were once limited by the supplies they could carry, until distant ports and coaling stations changed everything. These outposts turned oceans from barriers into highways. The same happened with railways. Water towers and depots enabled trains to cross continents. Infrastructure didn't just make old trips easier, it created new economies and possibilities. Orbital fuel depots are the 21st century equivalent, critical links that will open a new frontier. When a carried resource becomes a service, you get a revolution, not just an improvement. A network of fuel depots in space will be the foundation for a true space economy. Services, transportation, sustained presence. Infrastructure changes our perception of distance and possibility. What was once a perilous expedition becomes a routine trip. Refueling stations will domesticate the space between worlds. The moon becomes a manageable trip, not a monumental effort. This is how frontiers are settled, not with a single leap, but with steady, repeatable infrastructure. The future of space is built on the lessons of our past. Building orbital refueling infrastructure is a monumental engineering challenge. Refueling in orbit is a high-stakes ballet. Two vehicles must dock perfectly while hurtling through space. Once docked, transferring cryogenic fuels like liquid hydrogen in zero gravity is fraught with difficulty. Without gravity, liquids slosh, bubble, and resist flowing smoothly. New pumps, insulation, and techniques are needed to ensure safe, efficient transfer. Every component must be reliable. A single leak or stuck valve could doom a mission. Docking mechanisms and software must be flawless, the process nearly automated. Standardized ports and connectors will be essential, just as shipping containers revolutionized trade on Earth. The challenge is as much about policy and collaboration as technology. But mastering this cosmic ballet will unlock a new era of exploration. The true revolution comes when refueling is routine, reliable, and taken for granted. When mission planners can count on a fuel depot in orbit, spacecraft can be designed for their jobs, not just for launch. Imagine booking a refueling as easily as scheduling a cargo shipment. Missions to distant worlds become faster, more direct, and more responsive. Trust in this infrastructure ripples through design. Landers can launch empty, fill up in lunar orbit, and carry more crew and equipment. Specialization and reusability become possible. A space tug or lunar shuttle can fly dozens of missions, refueling after each. Costs drop, fleets grow, and space operations become sustainable. This is only possible when refueling is a dependable service, not a risky experiment. Predictability is the bedrock of our future in space. Routine refueling enables a new way of thinking, a modular, distributed architecture for space exploration. Instead of single monolithic missions, we build transportation systems, launchers, depots, tugs, landers, each optimized for its role. If one component fails, the mission isn't lost. You just launch a replacement. Capabilities grow piece by piece, like building a city brick by brick. This approach changes the economics. Companies can specialize in fuel delivery or cargo transport, creating a competitive marketplace. Agencies like NASA become customers, focusing on science and exploration, not owning every piece of hardware. Ambitions can scale, assemble massive ships in orbit, refuel at Mars. Journey onward. Refueling isn't just about cost. It's the foundation for a permanent human presence beyond Earth. The solar system becomes accessible, step by step. This is the architecture of our future in space. For decades, fuel has been our primary constraint, the rocket equation our master. Reliable orbital refueling promises to sever that tether for good. Fuel becomes a commodity, a service you schedule, not the central problem of spaceflight. The psychology of exploration changes, no longer rationing, but navigating from one supply point to the next. Engineers can focus on capability, comfort, and science, not just shaving grams. Lower costs and greater flexibility open space to more players. Universities, smaller countries, private companies. Activity in orbit explodes. The space around Earth becomes a bustling extension of the human sphere. This is the promise of routine refueling access, innovation, and a new era of exploration. The cosmos is no longer out of reach. We stand at a pivotal moment, ready to move from fleeting visits to a sustained presence in space. Refueling in orbit is the linchpin for lunar bases, Mars missions, and a vibrant space economy. It's the key that unlocks the next level of exploration. This is about more than technology. It's a change in perspective. We're building the ports, railways, and highways for the next great age of human expansion. The challenges are immense. but history shows the rewards are transformative. The planets and moons await, holding answers to our deepest questions. For too long, our journeys have been constrained by the fuel we can carry. Now, we're learning to live off the land, building the infrastructure to make the solar system our backyard. This is the beginning of the next great chapter in our cosmic story.